On March 23, 2012, NASA Mission Control informed the crew of International Space Station in space on radio that many micro-meteorites are going to hit ISS after 6 minutes. This radio message caused panic in the entire ISS. Astronauts had so little time that they could not even change the direction of the space station during this time. But the question is that in the part of space where ISS is present, there are countless micrometeorites. Then how does International Space Station, i.e. ISS, protect itself from these meteorites? How was this work done to change the direction of ISS, which weighs as much as 380 vehicles, without fuel and without help from Earth? How was this work done from armored in space, and how is it contacted when ISS is on the other side of Earth? We're seeing preparing it at a cost of $50 billion. Or 12,375 billion rupees. ISS is a home for humans in space, the example of which is unmatched in history. Hundreds of high-tech parts have been used to build it. It has 16 pressurized modules, which include separate modules for living and sleeping, an observation deck and 6 science labs, all of which are connected to each other through airtight tunnels. Along with this, many spots in the ISS are still lying vacant, some for parking extra capsules, while some have ISS lifeboards parked permanently so that in case of an emergency, if there is any problem, these lifeboards can safely take the astronauts to Earth. The International Space Station is the largest space station ever built. The ISS is as big as a football field, although it is 400 kilometers away from the ground, but still it can be seen from the ground with the help of binoculars. Then if you want to estimate its size from a real-life object, then understand that the International Space Station is as spread out as the bottom or base of Burj Khalifa. The total weight of ISS is 460,000 kilograms. This is the same weight as 380 cars or 25 passenger buses. But the question is, how did such a heavy and such a big ISS go into space? ISS started with just 2 modules, and both of them were connected to each other in space. One module was made by America and the other by Russia. In 1992, after the breakup of Soviet Union, America and Russia collaborated, and both the superpowers decided to build an International Space Station in space. First, Russia sent a module named Gyria into space, and then America sent its Unity behind it. Flying at a speed of 27,000 kilometers per hour, Unity connected Gyria. On November 20th, 1998, at 6:40 a.m., these 2 modules connected with each other 400 kilometers above the ground, and thus the International Space Station was born. Since then, in the last 26 years, engineers from all over the world have together built their own modules and sent them into space through rockets and connected them to the ISS. Today, apart from the US and Russia, European and Japanese modules are also connected to the International Space Station. From the year 2000 till today, not a single day has passed in the ISS in the last 24 years when it has been empty. At all times, astronauts from some country or the other are present in it. To fulfill the needs of the astronauts inside the ISS, all those facilities are present which should be there in any superstructure, out of which oxygen is the most important. A human being can survive without food for 3 weeks, without water for 3 days, and without oxygen for only can survive for 3 minutes 400 kilometers above the ground where there is neither atmosphere nor oxygen for breathing. The biggest challenge for the ISS is to provide fresh oxygen to the astronauts. An average human needs 15,000 liters or 22 kilograms of oxygen per day, providing about 200 kilograms of oxygen per day for the 9 astronauts. Living in the ISS is really a big challenge here. The astronauts have oxygen supply of several days in tanks so that if the system fails, then the oxygen supply is sufficient till the rockets arrive from the Earth so that the astronauts can survive. Today, the technology has become so advanced that oxygen supply can be delivered from the Earth to the ISS in just 6 hours, but only if the rocket launch is successful. This method is good but very costly, because it costs 200 million rupees for a cargo rocket to go from Earth to the ISS. It costs 50 crores of dollars. So food and other supplies are sent once in several months, but to fulfill the daily oxygen demand of 200 kilograms, it is very difficult to use rockets again and again. That is why ISS produces its own oxygen. Without any dependence on Earth, it has a small machine which produces oxygen using nothing else but water. When electricity is passed through water, it breaks into 2 parts hydrogen, and oxygen bubbles of hydrogen gas get collected on the positive electrode, and oxygen gas bubbles get collected on the negative electrode. Now, if the same experiment is done on Earth, then these bubbles get separated from water automatically, because obviously the weight of gas is less than water. But there is no gravity in space. The weight of gas is same as that of water, i.e. it's almost zero. So now, to separate oxygen gas from water, this machine is used. It is rotated in a circular motion, which creates centrifugal force, which works as an artificial gravity. Due to rotation, water goes to the sides and oxygen gas remains in the middle, which the machine collects on its own and puts it in a container. Now you must be thinking that if oxygen is made from water in ISS, then from where does water come in space? Here also the brilliant engineering shows its magic. In this process, the hydrogen gas coming out is reacted with the carbon dioxide gas coming out of the astronaut's breath and is again converted into water, and finally methane gas is left, which is released into space. Making oxygen for the International Space Station is a huge challenge in itself, but an even bigger challenge is to save this oxygen, because if even a small hole is made in the space station, then its result can be very terrible. In a second, the space station can explode into pieces. The example of Titan submersible, which was destroyed recently, is in front of all of us. The pressure in the ocean is high, whereas Titan had controlled pressure. As soon as its hull leaked, the ocean pressure compressed it badly in less than a second. But in space, it is just the opposite. Here, the pressure outside is zero, whereas the pressure inside the ISS is maintained just like Titan. If there is even a small crack in it, it will decompress and burst. At the height at which the ISS orbits the Earth, there are a lot of space debris which are moving in space at a very high speed. These include parts of satellites and hundreds of small and big meteors. So the question arises that how does the ISS protect itself from these debris? The International Space Station is orbiting the Earth at a speed of 27,000 kilometers per hour. This is such a fast speed that if it comes close to the Earth at such a speed, then it will explode. If it flies, it can cross the Pacific Ocean in just 25 minutes, the same Pacific Ocean which takes 13 hours for commercial planes to cross. If it collides with a meteor as big as a grain of sand at such a high speed, it will be like a car colliding with a tree at a speed of 80 kilometers per hour. On March 23, 2012, NASA Mission Control radioed the ISS crew that some space debris was heading straight for the ISS. Nobody knew how big this debris was. They were informed just 6 minutes beforehand. The entire crew immediately went into the lifeboats, but luckily the space debris passed very close to the ISS without touching it. But the ISS cannot be left to luck every time against a meteor. To avoid even small particles, the hull of the ISS was made of bulletproof material, just like bulletproof vests. There are different layers. Similarly, the hull of ISS was also made by combining different layers. The outermost layer, it is made of aluminium, then a layer of woven material, and inside that, 12 layers of aluminium. A single metal is not so strong that the same metal can be cut and spread in 2 or more layers. Every time the ISS passes, micro-meteorites as big as grains of sand are attacking it, but it is its bulletproof layers that have been protecting the ISS for the last 26 years. But what will happen if a big meteorite comes in the way of the ISS? It is not as big as a car, but just 1 inch big. In this case, if it hits at such a speed, even the bulletproofing of the ISS will be of no use. The mission control crew on the ground already has an idea of the location and position of the incoming meteorite. If it is of a type that can cause damage, then in this situation, the entire ISS has to be moved out of the way. The small thrusters installed in the ISS can be used to avoid it. The trajectory can be changed, but these thrusters run on rocket fuel, and this fuel is very less with the ISS. It is only for emergency purposes. To end the dependency of ISS on Earth, a mechanism has been installed in it which can easily change the direction of the ISS, weighing 460,000 kilograms without using rocket fuel. Small boxes are fitted in its center, which are called control movement gyroscope or CMG. But how do they change the direction of the ISS, which is as big as a football field? Inside these boxes are flywheels which spin at a speed of 6,600 rounds per minute. Flywheels are like heavy round wheels, just like the wheels of a train. When they are spun at high speed, angular momentum is generated in it. This momentum is transferred to the entire body of the ISS, and in this way the entire ISS moves. It starts moving in one direction. If the flywheel is rotating very fast, then the direction of the ISS will change more and the ISS will rotate in the same direction. If the ISS has to be rotated in the opposite direction, then the flywheel is also made to spin in the opposite direction. These flywheels are rotated with the help of electricity, which is generated by the solar panels installed in the ISS. Since we are talking about solar panels, let us tell you that these solar panels are movable because the ISS is orbiting the Earth so fast that the sun rises here 16 times in a day, and even when the sun rises, it shifts its position so fast that if the solar panels are fixed, then direct sunlight will not fall on them and they will not be able to produce electricity properly. That is why these solar panels installed in the ISS always keep their direction towards the sun. Solar panels produce 120 kilowatts of electricity at a time. This is the same amount of electricity that can easily run 110 air conditioners on Earth. Keeping in touch with the astronauts on the International Space Station used to be a big challenge for mission control. Communication takes place through radio signals. These signals cannot cross the Earth, and often the ISS is on the other side of the Earth. To solve this problem, airplanes were flown earlier which would catch the radio signals of the ISS and transmit them to mission control in Houston. This method was costly as well as quite unreliable. Often the connection with the ISS would be disconnected for up to an hour until it orbited the Earth again and came within the range of mission control. But this does not happen now. With the advancement in technology, the communication problem is solved with the help of high Earth orbit satellites. Now it is over forever. Whenever the ISS has to contact mission control, the satellite first catches the signals. Then the same signal is sent to the network of satellites. And then whichever satellite is in range relays the signal to Houston Mission Control. This way, now the astronauts present in the ISS can easily connect with their families with a delay of just a few seconds. Scientists from all over the world have been trying to make the ISS self-sufficient for the last 26 years. A space station that needs the Earth as little as possible. Many inventions have been made for this purpose, but there are still many requirements which need the help of Earth to be fulfilled, such as food items, chemicals to filter water, spare parts, and shifting of the crew, because an astronaut cannot stay in space for more than a month on the International Space Station. There are many labs to do different types of experiments, most of which are done on human body. The purpose is only to find out what difficulties humans may face when they go to Mars or deep space. ISS is only 6 hours away from Earth, but when humans go to Mars, there will be neither support from Earth nor the way back will be so easy. Hope you all will like and share this video.